All right, guys. Hello. I'm Mr. Silva, obviously, and I dressed up for the occasion. I had to be fancy to do the first lesson for Math 7. We're going to be doing estimating angle measures and distributed property with algebraic terms. This is one of those lessons that I don't think that the book has it quite right. I think they should have put distributed property with algebraic terms as their own lesson because it's really important. But, the book does what it does. And so for the first part, you might need to use a protractor. So I unfortunately don't have mine. I left mine at school. I didn't see the lesson before I came home. So I'm going to try to explain it to you with the images in the book later on. But first and foremost, we're going to start with this first part, the second part of the lesson, which is distributed property with algebraic terms, which is really important. So let's get into it. Okay, so to be able to do this problem, we have 2 times x plus 3 in parentheses. So we're going to distribute like we have done before. So the little arrows, the multiplication, 2 times x is 2x, and 2 times 3 is plus 6, and that's it. We're done in this one. So that's what you do in this one. And here we have negative 2x minus 3. Here we have to be careful because of the signs. So it's going to be negative 2 times x and negative 2 times negative 3. This is positive 3. This is negative 3. So it's going to be negative 2 times x is going to be negative 2x because that's what negative 2 times x is. And then negative 2 times negative 3, because negative and negative is positive, would give you 6. So that's what that part is. For the other 2 examples, we have negative 2 times x plus 3, and so we're going to do negative 2 times x and negative 2 times positive 3. Negative 2 times x is going to be negative 2x, just like in the previous example. And then negative 2 times positive 3 is going to be negative, and positive is going to be negative. And then 2 times 3 is going to be 6. So that would be that one. And in here we have something a little bit different, but still pretty much what we have done before, x times x, and then we have x times negative 3. So x times x is going to be x squared, and x times negative 3 is going to be negative 3x. Because they're not alike, they're not like terms, we're not going to combine, so that would be the answer. In example 2, we have something a little bit different because we have distributed property, and then at the end we have to combine like terms. So we have to be careful about what we're doing. So first we have to do distributed property, then we're going to combine like terms. So the first thing we're going to do is multiply positive 3 times x and positive 3 times negative 2. So it would be x squared plus 2x plus 3 times x is 3x, and 3 times negative 2 is going to be negative 6. And then we're going to combine like terms because this one has just x squared and none of the other terms have an x squared. It's just going to be that. For this one, 2x, it's very similar or is alike to 3x because they have a constant and a variable with the exponent of 1. So that's why they're alike. They're like terms. And this one, being just a constant, is going to be by itself. Because we underlined 3 different types of terms, we're just going to end up with 3 for our answer. So it's going to be x squared. 2 plus 3 is 5x minus 6. This one has 1 underline. This one has 2 underlines. This one has 3 underlines. And I know that this is my answer. And for the last example, this is very similar to what we have done before. It's going to be x squared, 2x minus 3, x minus 2. So the only difference is the minus 3 here. And again, we're going to distribute first. So the 3 to the x and the negative 3 to the x and the negative 3 to the negative 2. And then when we do that, it's going to be x squared plus 2x Negative 3 times x is negative 3x. Negative 3 times negative 2 is going to be positive 6. Again, this is by itself because it has squared, x squared. These two are alike. And this one is by itself because it has no variable. And so it would end up being x squared plus, what is 2x minus 3x is not plus. It's actually positive 2 minus 3, or 2 minus 3 is going to be minus 1, negative 1. And so it's going to be minus x plus 6. This has 3 underlines. This has 2 underlines. This has 1 underline. I know I'm done because that's what the underlines say. For the last example, and it's not about distributive property, it's about the previous thing that I told you about, the one with the protractor. You'll see here that we have a protractor, and you'll find in your book that we have the 180 on the outside and the 0 on the inside. So we're supposed to measure from the little mark in the center of the protractor and line it up with the 0 degree or 180 degree to the right, and then that will actually make the angle measure right here. And so what happens is that this angle measure, it's supposed to be an approximation. We don't know what it is, so we're supposed to go from the 0, which is the inside of the protractor. But again, I told you in class that protractors are different. Some have it on the outside, some have it in the inside, the zeros, but both will actually, all protractors would actually have a 0 or a 180 in this position right here. Some are going to be the 180 in the inside, some have the 0 on the outside, but this one right here has it on the inside. And so we're going to go 0, 10, 20, 30, 40, 50, 60, 70. And it's going to be between 70 and 80. So that's why the book says the best estimation between for this angle BOC is going to be 75 degrees. And that is how you measure with the protractor, just in case some of you have forgotten. And that's pretty much lesson 96.